Hi all, let's see the next topic of Unit 2, Data Manipulation Instructions. Coming to the contents, we are going to discuss about an introduction to data manipulation instructions and types of data manipulation instructions. So data manipulation. So data manipulation refers to the process that transform and operate on the data to produce the desired outcome. So these data manipulation instructions, they basically perform operations on the data which is stored in the registers, and they provide computational capabilities to your computer. So they include some set of instructions like operations like arithmetic operations, logical operations, bit level operation manipulations, uh, shift operations. All these operations, they work on they perform manipulations on the data which is stored in your computer system. These data manipulation instructions are primarily categorized into three types: arithmetic instructions, logical and bit manipulation instructions, and shift instructions. We'll see in detail about each type of the instructions. So coming to arithmetic instructions, the arithmetic instructions include operations, perform operations such as increment, decrement, add, subtract, multiply, divide, add with carry, subtract with borrow, negate. Negate is nothing but two's complement. So all these are nothing but arithmetic operations. So these arithmetic instructions perform these type of arithmetic operations. If there is a negative number, if you want to include a negative number in your operation, it is considered as a negate. So this tabular column will give you the list of arithmetic instructions: increment, decrement, add, subtract, multiplication, division. This is add with carry, subtract with borrow, and negate. Negate is nothing but the two's complement. So we'll see in detail about each type of an arithmetic operation. Arithmetic instruction. So the first type of an instruction is an increment. So the mnemonic that is used is INC. If you see an example of this in INC R1, it means that it increases the value or increments the value stored in a register R1 by 1. Increment is always incrementing the value of a content of the particular register by 1. So R1 implies R1 plus 1. The contents of the register R1 are incremented by 1, and the result is again stored into the R1 register. Next is the decrement operation. Decrement instruction represented by DEC. So DEC of R2 means it decreases the value stored in the register R2 by 1. So R2 implies R2 minus 1. Next type of an instruction is add, which performs addition operation on the contents of either two registers. If you consider an example, add R3 comma R4. It adds a value in register R4 to the value in register R3, and the result is stored back into the one of the source register R3. So R3 implies R3 plus R4. Next is the subtraction operation. So it is represented by sub. So sub of R5 comma R6 means it subtracts the value in register R6 from the value in register R5, and result is stored back in again in register R5. So R5 implies R5 minus R6. Next type of an arithmetic instruction is a multiply, represented by mul. It performs a multiplication operation on the contents of two registers. So mul R7 comma R8. It multiplies the values in register R7 by the value in register R8. So R7 implies R7 into R8. It performs a multiplication operation. So we'll next type of a arithmetic instruction is a divide, represented by div. So div r9 comma r10 means that it divides the value in register r9 by the value in register r10. So r9 implies r9 by r10, and the result is stored back in r9. So next type of an instruction is add with carry. So addition along with a carry bit. So we represent it as add C, addition with a carry. So add C of R11 comma R12 means that the contents of it adds a value in register R12 and the carry flag to R1. So the contents of R11, so add C of R11 comma R12 means that it adds a value in register R12 and the carry flag to register R11. So R11 implies R11 plus R12 along with the carry flag. Next is subtract with borrow, represented by sub B. Example, sub B of R3, R13, R14 means that it subtracts the value in R14 and the borrow flag from R13. So R13 implies R13 minus R14 minus carry flag. Whatever is there in the carry flag, whether it is 1 or 0, along with the borrow, that the particular subtraction operation is performed. Next is a negate, which is nothing but the 2's complement, represented by NEG. So, for example, NEG of B, if it means that it will negate a value by finding the 2's complement of an operand. So, here the operand means that B. So, this means we are going to perform a complement, one's complement on the particular operand and add 1 to it. So, one's complement plus 1 means 2's complement. So, we are performing the 2's complement of B by performing a 1's complement. 1's complement means the contents of the register ones become zeros and zeros becomes ones. So, and then after performing the complement operation, we are going to add 1 to it to get the 2's complement of B. So, that is nothing but negate instruction. So, these are the list of arithmetic instructions. Next, coming to a second set of data manipulation instructions, which are logical and bit manipulation instructions. So, logical instructions, they perform binary operations on string of bits which are stored in the registers. And these are helpful for manipulating the individual bits or a group of bits. You can perform the entire group of bits which are stored in the registers, or you can perform operations or manipulations on the individual bits of the register. So that's why we call them as a bit manipulation instructions. So this table will give you a list of logical and bit manipulation instructions. Clear, represented by CLR, complement, and, or, XOR. These are the logical instructions. And then set clear to set your carry, clear carry clear your carry bit. And to set C means set carry, to set your carry bit. Complement carry, enable interrupt and disable interrupt. So all these are the set of logical and bit manipulation instructions. We'll see in detail. The first type of an instruction is a clear instruction, represented by a mnemonic CLR. And example, if you take CLR of R1, it sets the value in the register R1 to 0 because this is a clear operation. It clears the contents of a specific register. So R1 is cleared to 0. Next is a complement instruction. So represented by COM. COM of R2 means that it inverts all the bits in the register contents of the register. So which means if my contents of my register R2 contains 0000, if I perform a complement operation, what happens? The zeros becomes ones. If there are ones in my registers, it becomes zeros. Since in this register R2 I have all zeros, if I implement a complement operation, all the contents of my register R2 become 1111. So that is called complement. So that is represented as R2 complement. And the result is stored again into R2 register. So the next instruction is an AND instruction. It performs a bitwise AND operation between the contents of two registers R3 and R4 and stores the result back into R3 register. So it performs R3 and R4 and the result is stored back into R3 register. The next type of an instruction is an OR instruction represented by OR. So it performs OR R5, R6. It performs a bitwise OR operation between the contents of register R5 and R6 and stores the result back into R5 register. So it performs R5 or R6 operation and the result is stored into R5 register. And next is an exclusive OR represented by XOR. It performs a bitwise XOR operation between the contents of two registers R7 and R8 and stores the result back into R7 register. So R7 implies R7 XOR R8. The next instruction is a clear carry represented by CLRC. This instruction is used to clear your carry flag. If there are any contents in your carry flag, that will be cleared to 0. So that is represented by carry flag is cleared to 0. CLRC. Set carry. Set carry is used to set the carry flag to 1. So using set C instruction, the carry flag will be set to 1. Next is a complement carry. So that is used to invert the carry flag. If carry flag contains 1, to make it 0, we implement a complement. If the carry flag contains 0, to make it 1, you can do it using a complement carry. So whatever is the value of your carry flag, if it was 1, it becomes 0, and if it was 0, it becomes 1, vice versa. So that is done by means of a complement carry instruction. So carry flag will be complemented and the result will be stored. Complemented flag values result will be stored into the same carry flag. Next is the enable interrupt and which is represented by EI. So EI, it is your instruction enables the interrupt system which allows the interrupts to occur so that the CPU can handle the interrupts. In case of a disable interrupt, if the CPU does not no longer want to be interrupted, it will just execute this disable interrupt instruction so that it disables the interrupt system, preventing the interrupts from occurring. So these are the list of logical and bit manipulation instructions.